All of us have been to a playground and we have thrown a ball up in the air and then caught it back. That is one of the most common examples of vertical motion of an object under the effect of gravity. Here we will have a very close look at vertical motion under gravity and look at various parts of that particular motion. Right? What is happening when the ball is going up? What is happening when the ball is going down? And we will also look at the physical quantities like the initial velocity, final velocity, acceleration, displacement, and time, and how these physical parameters are interconnected when an object is undergoing vertical motion under gravity. So let's start. Let's say this is a playground, right? And there's a player over here, right? He throws a ball up in the air. This is the ball moving from his hand. It goes up into the air, reaches this particular height, right? And then comes back and is over here. And here, let us say the person catches this ball again. Right? So if you look at this particular motion, we're seeing vertical motion upwards, vertical motion downwards. And I can break this up into two parts, A, B, and C. So AB is the vertical motion going up and vertical BC is the vertical motion going down. Let us look at the various parts. Let us begin with the first point, right, at location A, right? What is happening at location A? At location A, the object is leaving the ball, the object, that in this case the ball, is leaving the hand of the thrower. Right? When the ball leaves the hand of the thrower, the initial velocity u, and we'll call it ua, right, will have some particular value. It will not be equal to 0. It will have some value. So ua will have some value. Now, sometimes we think that since the ball is stationary in our hand, the initial velocity is 0. That is not the case. When the ball, we have to consider the initial velocity when the ball leaves our hand, because when it leaves our hand, it is under the effect of gravity. While it is in our hand, it is not under the effect of gravity. Right? Our hand is applying a force on the ball and it is preventing it from coming under the influence of gravity completely. Right? The moment it leaves our hand, it is under the influence of the gravitational force. Hence, we have to look at the situation of the ball or the forces acting on the ball the moment it is out of our hands. And at that point in time, initial velocity will have some value. Initial velocity is not 0. That is point number 1. The second part is when it is moving from A to B, right? The motion A to B. While it is moving from A to B, right, the ball is going in the upward direction, but the gravitational force is acting in the downward direction. Right? Therefore, during AB, the velocity of the ball is decreasing. Now, sometimes this particular thing also might create some confusion in the minds of people. What we feel is that the ball was stationary in our hand, we applied a force and we threw it up in the air. Since the ball was stationary and since I have applied a force, there is an increase in velocity. But again, we are looking at the motion after the ball has left the hand. The moment it has left the hand, it is under the influence of gravity. As it starts going up, what is happening is the gravitational force is applying a downward force on it and thereby reducing its velocity. And as you would have experienced, it stops over here. When it reaches its maximum height, because its velocity is decreasing, it stops over here and then starts coming down. So this is the second point that I want you to understand very clearly, that when the ball is going up, the velocity of the ball is decreasing. The third is during this journey AB, right, the acceleration of the ball is given by minus g. Right? G is equal to 9.8 meter per second square. So the acceleration of the ball is 9.8 meter per second square, but we assign a negative sign because it is deaccelerating, or we have negative acceleration because the velocity of the ball is decreasing, and hence the value of g is minus g over here. Point number 4, at B. At B, the velocity of the ball is equal to 0. The ball stops momentarily over here and starts coming down. So at B, velocity is equal to 0. Now let us move to this part BC, right? And that will be the fifth point. In the journey BC, right, the velocity of the ball is increasing. Right? Because the ball starts going down, the gravitational force accelerates. So we have positive acceleration. So the value of g would be plus g. Right? G is 9.8, but it will have a positive sign because it is increasing the velocity. And finally, it will reach a very high value over here. Right? So these are the main differences between the upward motion and the downward motion. Initial velocity will have some value, velocity will decrease, become 0, the velocity increases, and we have some velocity over here. Point number 7. When it reaches this particular location, right, and if I assume that these two are at the same height, right, then if I call this velocity as Vc, the final velocity at location C, that will be equal to UA, the initial velocity over here. Two conditions are required for that. Both these are at the same height from the ground, right? And two, we ignore frictional losses, friction due to air. Right? So if we ignore losses and if we assume that these two are at the same height, then the initial velocity over here and the final velocity over here is equal. So these are some of the things that we need to keep in mind when we are looking at vertical motion under gravity. Okay, let us go back to the motion AB, right? Journey AB rather. In journey AB, you will have UA as the initial velocity. Final velocity is equal to 0. Acceleration is minus g as we discussed, right? So if I want to find out this particular displacement, the shortest distance between point A and B. Note that we are not finding out distance, we are finding out displacement, the shortest distance between A and B, right? That can be obtained by using the equation S is equal to UT plus half AT square is equal to UA into T plus half G is minus G, so minus G T square. So S will be equal to UAT minus half GT square. And this is one of the equations that we may want to underline. Right? Equation 1, S is equal to UAT minus half GT square. Now if I use the equation V square minus U square is equal to 2AS. For this particular journey, V is 0, final velocity is 0. So 0 minus UA square, initial velocity is UA, is equal to 2 minus G into S. And therefore you will get UA square is equal to 2GS. The minus signs will vanish and you will get UA is equal to square root of 2GS. It's the second equation. Right? So I have an equation for calculating the height through which the object goes and its initial velocity. Right? UA is equal to 2GS if I know the height. Right? For a body which is thrown up or which is going up. I can do the similar thing for the journey BC, right? When the object is going up. For this, U is equal to 0, initial velocity is 0, final velocity is VC, acceleration is plus G. Right? So if I use again this equation, S is equal to UT plus half AT square is equal to initial velocity is 0, so this term will vanish because U is 0, we will be left only with half AT square. So it will become half GT square. S is equal to half GT square. Let me rewrite. S is equal to half GT square. This is equation 2. Let us say this is equation 3. Again using this equation, V square minus U square is equal to 2AS. U is 0, so this term will vanish. So you'll get V square is equal to 2GS. And V is equal to square root of 2GS. Final velocity is Vc. So Vc is equal to square root of 2GS. Right? This is equation 4. So this will give me the final velocity, the velocity when the ball reaches this particular location. So Vc is equal to square root of 2GS. And you can see these two equations are same. But again, to repeat, if we ignore frictional losses and these two are at the same height, when S are equal. So these are the equations that you may want to use whenever you are dealing with questions related to vertical motion under gravity. Before I wind up the video, one more point, and that is related to an object which is falling down, that is part BC, right? In this particular part, there are two possibilities. One possibility is that the object is dropped, right? And two, object is thrown down, right? So somebody says, say for example, we have this is a ground and this is a tower, and let's say there's a person standing here with a ball. Now he can simply drop the ball or he can throw the ball down. The difference is when the ball is simply dropped, when the ball is simply released, you can take U as 0. The initial velocity can be taken as 0. Whereas when the ball is thrown, right, initial velocity will have certain value. It will not be equal to 0, it will have some value. This is the thing that you need to keep in mind whenever we are looking at a body freely falling down, when it is being dropped or it is being thrown. Right. So with this, I have covered vertical motion under gravity. Keep these concepts in mind whenever you are looking at vertical motion under gravity. In the next video, I'll pick up a couple of numericals and apply these principles to vertical motion of gravity, which will help you understand all these concepts much better. Thank you for joining me on this video on vertical motion under gravity.